Hello everyone, good morning, good afternoon, and good evening, wherever you are in the world. Welcome to my channel. In today's video, we will walk through another sample problems on how to design the beam shear reinforcement, part 2. And our calculation, we covering 3 key topics related to the design of shear reinforcement in beams. So the first one is determining the shear force at the face of the support, VU, and the adjusted shear force VD at the distance D from the face of the support. The second one, I will discuss using the graphical approach to understand the relationship between the concrete shear strength and the reinforcement shear strength here. So the third one, calculating the theoretical stirrup spacing and finalizing the selection based on the design requirements. So let's dive into our problem. Select the number 3 used stirrups for the beam shown in the figure below, for which the dead load is equal to 4 kips per foot and live load of 6 kips per foot. So we are given 4,000 psi using normal weight of concrete and the yield strength of steel, which is 60,000 psi. So we have the beam here, 14 feet long, the span of the beam. So uniformly, so we expect that the shear at the end of support is just divided by 2. So we have here, we just consider this portion here, which is 7 feet. We will calculate the VU based on that one. And we have the section of the beam, which is 15 inches and by 22.5 inches in the effective depth of the beam. So let's get started with the solution. First of all, we need to determine the VU, which is 7 feet times 1.2 times 4 kips per foot plus 1.6 times 6 kips per foot, which is equal to 100.3 kips or 100,800 pounds. So the next one is to determine the VD, the VU, the shear force from the face of the force at a distance D. So VD, if we determine VD by ratio and proportion, this one here, we just extracted it from here, this one here. So that is 100,800 pounds is to 84 inches, that is 7 feet. This is in inches, 84 inches, equal to VD is to 84 inches minus 22.5 inches. So VD, so this is how we come up this expression here, this equation. So that is equal to 73,800 pounds. So the next one is we will determine the shear strength of the concrete. So based on the ACI table 22551, we have phi times 2 times lambda square root of FC prime times BD, the section of the beam. Then VC is equal to 0.75 times 2 times 1 times to the square root of the strength of concrete, 4,000 psi, times the width of the beam, 15 inches, times the depth, 22.5 inches, that is equal to 32,018 pounds. So then this value, we will reflect this on the diagram here. If you notice, this 32,018 pounds is plotted in this diagram here. This is PBC here. Then the next one is we will calculate the VU, VS. So VS, we have VU is equal to PBC plus PBS. P here is 0.75. So to calculate the PBS is equal to VU minus PBC. So BU is 73,800 pounds. which is come from here, minus 32,018 pounds, that is equal to 41,782 pounds. So to calculate the BS is equal to 41,782 pounds divided by 0.75. So this is the value of BS, 55,709. We are calculating this because we are going to calculate the spacing of the stirrups from the distance D from the face of the support. So to compute the maximum spacing based on the ACI code 97622, D over 2 is less than or equal to 24 inches. That is if BS is less than or equal to 4 times the square root of FC prime BD, which is the width of the beam times the effective depth. So calculating this, to calculate this formula, we have 4 times the square root of 4,000 PSI times 15 inches times 22.5 is equal to 85,382 pounds, which is greater than BS. So BS here is, since BS is less than, the maximum spacing is D over 2. 22.5 over 2, that is 11.25 inches. This is the maximum spacing based on this ACI code requirements. So the next one is to determine the maximum theoretical spacing of stirrups at the distance D from the face of the support, which is this one here, from the face of the support to here. So is equal to EB times Fy times D over BS. So 2 times 0.11 square inch. So 2, because we are using the 2 legs of stirrups, times 0.11 square inch, that is the area of 1 leg of the ties, which is number 3. So times 60,000 PSI times the depth, 22.5 over 55,709 pounds, that is BS, is equal to 5.33 inches. So this is the spacing of the stirrups from the face of the support. This is the controlling one based on the ACI code 22.5.1053, which is this formula. The next one is to calculate the maximum spacing to provide minimum EV or transverse reinforcement based on the ACI code section 9633. So the equation we have is S is equal to EV times Fy over 0.75 square root of FC prime times B. Width of beam is equal to times 0.11 square inch times 60,000 PSI over 0.75 times square root of 4,000 PSI times the width, which is 15 inches. That is equivalent to equal to 18.55 inches. So the other provision is S is equal to EB Fy over 50 times the width of the beam is equal to times the area of the stirrups, 0.11 square inch times 60,000 PSI over 50 times the width of the beam, 15 inches, that is equal to 17.6 inches. So if you notice, this spacing is controlling. So the next one is to determine if we use the spacing of stirrups at 9 inches on centers. So we need to locate where is this location in the chart here, in the diagram. So if we use the spacing, we need to locate what is the value of VU, so that we can calculate the location from the face of the support by using the ratio and proportion. So VU is equal to VC plus P times EB times Fy times D over S. So if you substitute this portion here to VS, you will have this expression here. So BS is equal to, VU is equal to 32,018 pounds plus 0.75 times 2, 0.11 square inch times 60,000 psi times 22.5 inches over 9 inches. 9 inches is the spacing. So we got the value of VU 56,768 pounds. So if we look at the chart, maybe somewhere here, because this one is 73,800, so this one is 32,018 pounds, so somewhere here in the middle, more or less. So to calculate that, the shear, the location of the shear from the face of the support, we need to use the ratio and proportion. So if we have this one here, which is similar to this one, triangle, 100,800 is to 7 feet. So we have 56,768 pounds is to 7 minus x. So we have this equation here. Then we have the unknown x. So calculating the x is 3.06 feet, which is equivalent to 36.69 inches. So from the face of the support, that is 3.06. So that is the required spacing, 9 inches on center, if you use that spacing. So the next one is to determine at what location can stirrup be terminated. So if when the VU is less than to PBC over 2, stirrups are not required. That is according to the ACI Code 9631. So if this is the PBC over 2 is 32,018 pounds, that is equal to 16,009. So if we look at to the diagram here, that location is somewhere here, 16,009. So that is from the face of the support to here. This is the location where the stirrups are required. So theoretically, beyond that point, stirrups are no longer required. So we'll check how we come up this 71 inches. So here, by ratio and proportion, the same pattern what we have calculated here actually. So 100,000 divided by 7 is equal to 16,009 pounds. Divide by 7 minus x. So x is equal to 5.89 feet, which is equal to 70.66. So that is run up to 71 inches. So this is the location where we need to provide the stirrups. Then the next one is the summary or tabulation of the spacing of the stirrups here. Result of similar calculation that we relate the value of x to stirrup spacing. So the same pattern actually what we have calculated previously. So if we already calculated this spacing 5.33 inches at the distance d from the face of the support. Now, if we determine the spacing of stirrups 6 inches on centers, so the location of that is 26.38 inches from the face of the support, the distance from the face of the support. So let's say if we want to check the location of the stirrups, if we want to have this 7 inches on center spacing, so that location is 30.8 from the face of the support. So similarly, 8 inches on center, we have 34.11 inches. So if you remember, we have already calculated the 9 inches, that is 30 36.69. It is not shown here because we have calculated that already manually previously. So in summary, we have selected the spacing of the stirrups. We have one at 2 inches. One stirrups placed at 2 inches from the face of the support. Then now 8 pieces of stirrups spaced at 5 inches on center. That is 40. So 40 plus 2, that's the cumulative distance. That would be 42 inches. So if you notice here, this is a little bit higher than what we have calculated previously, 36.69. So that would be okay. Then we still have to provide 9 inches spacing on center. So roughly 4 stirrups at 9 inches on center, that would be 36. So 36 plus 42, that would be 79. So if you remember, this 70.6666 is this one here, from here to there. So actually we use if we use that 4, 9 on center, so we come up 78 inches, so a little bit somewhere here. So we are a little bit conservative. Since our in this example we have only 14 feet beam, so it's not actually 2 sets of types of spacing, which is 5 inches on center and 9 inches on center. That would be okay. So we have here the partial elevation of the beam reflecting all the arrangement of the transverse reinforcement, which is the stirrups. So this is the one here. We 8 pieces, number 3 bars, 5 on centers, and we have the rest. You can use 9 inches on centers. But maybe guys, if you are using let's say a longer span, let's say 20 feet or 25 feet, you can variate that into different schemes. We have this tabulation here, so it depends on you. That is based on your engineering judgment on the site. So this is the end of our discussion, guys, for this topic. So thank you very much, and don't forget to like if you found this video helpful, and if you learned something regarding on this topic. So thank you very much. See you next time. Bye-bye.